So we are talking about a budding quantum ecosystem, but I think for many people, maybe also in the audience, this is quite abstract. So maybe to start a discussion with a very short round, maybe Kevin, you want to start. So what did change during the last maybe 2-3 years here in Munich and maybe also in Europe that we can really talk about a budding quantum ecosystem?
Yeah, so I think what came from research was like a really good base to talk about industrial use cases. So we are not building quantum computers, but as said, quantum sensing. So we had these very good systems in the university, and then also as part of the Munich Quantum Valley and the UnternehmerTUM, we explored different use cases. So we had a very sound scientific base to explore the different use cases, and all of this in a very fast manner. So I remember still when we were at the Muckel, the co-lab in Munich, where Infineon also has an innovation department, so we could get to the Infineon people, talk to them about a potential use of those quantum sensors in the semiconductor industry. And I think this ecosystem of the industry paying attention to what's developed on the research side, but also teams building up, raising first funds to deploy a first prototype, I think this is what really has changed.
Okay, so we have advancement on the technology side, on the market side. Jasmin, anything to add here from your side?
Yeah, I think the Munich Quantum Valley was really a big sign that Bavaria wants to do something. And I believe it is very important to understand if you invest in the quantum space, you don't need to invest in computing, hardware or software only. You can also invest in sensing. We are an investor in Kevin's company and also in communication. And sensing is already market ready. Communication, I would say also, although they depend a little bit more on the public hand and on the infrastructure investments. And computing, I don't think there are any fundamental challenges anymore. It's just an engineering problem. It's a very hard engineering problem, of course, but I think there is more diversity in the field, as many people, also LPs and entrepreneurs often think, because they are very skeptical if you say that you invest in quantum with your fund. But I think we all need to do it in the deep tech ecosystem.
Okay, so it's extremely important to understand that there are different clusters within quantum when it comes to the maturity of the technology, maybe.
Yeah.
So Sabine, you are the CTO of Airbus. We will go into detail later on, but maybe to start a conversation. So what's your view on that? What happened during the last years here that changed so much?
Yeah, and of course, as an industrial player, we are not actually building the compute power, but we are using it. So we are looking from a user standpoint, and you said it, the aerospace sector is maybe one of the ones who's really looking for a step change in the compute power. So we are always looking for the most value we can get out of this, because we have huge models to simulate. So the more we can actually go into fast and furious, that will help. And then of course as well all the technologies that we can integrate. So we are playing an integrator role into our overall system. So what has changed in the last couple of years? We do really think, yes, we are coming out of the lab stage into the industrialization stage. So it's not a question for us if it will work anymore. But it's clear that it will work, and it's more a question, how can we pull that it's coming quickly? Yeah. And on the other end, then looking at how we can integrate and what is our role in this integration. And of course, that's then really an ecosystem approach.
Yeah, great to hear talking about quantum computers, because that's what you're developing, Marcus. So you are developing a quantum computer. So what, in your perspective, did change that enabled that during the last years?
I mean, there's a lot of things. So first of all, what Sabine was mentioning is this kind of mindset change. Like, so in the beginning, it was maybe kind of something esoteric, where I think people, it's a really crazy thing to do. But in recent years, so the question is not like, if it matters at all, but the question is like when we have the computational power to really tackle industrial problems. So with this mind change, a lot of things went on. So surely we have this emergence of an ecosystem, which means something like we have talent, we have really good research, we have suppliers, we have a lot of investments. We have software providers which makes access easy. We even have like hyperscalers which are like exposing this thing. So if you want to play around with that, today it's easy. When you look like 10 years, 20 years ago, it was like something for, I would say, really technically oriented people who can read papers. Now you can click somewhere and you can spin up, say, access to a kind of quantum computer. They're still maybe not like in a technical hardy stage, but you have access, you have software tools, and this changed a lot. And so also with that comes then the interest of industry.
So luckily a lot happened, but maybe Sabine, going into real use cases, because from a aerospace system integrator perspective, where are the real use cases you see already today?
Yeah, I mean, generally, it's not the question what is the most valuable use case. It's really about getting it going.
Yeah.
But we are engaging in all types of quantum, so quantum computing, quantum sensing, and as well communication. Whereas, yes, it's just as an example, so we are flying quantum sensors today because we do think that this will be a step change in improving the navigation capabilities that we can have. So here we are going into, you have measurements and then magnetic maps of the magnetic fields around the Earth, and you can do navigation with this. So that will be one step in the future. So it's still some years to go because we need certification and everything, but that's flying today in real test flights. We also did, for instance, a quantum challenge together with BMW. So we are playing over our own branch here in the last year, and we had more than 100 proposals coming in. So it's really coming to play. And then, yes, if we look at another case where it's really about compute power, it's all our fluid dynamic simulations. So that's flight physics. How do we get to the most efficient design of an aircraft, and especially when we are looking to emissions, sustainability improvements, and hence efficiency of the aircraft, then it's really about, yes, AI-based models and compute power that can make that step change. So we are looking forward into when is the D-Day, the ChatGPT day of quantum, so that we can, we are convinced that it will come and that it will make step changes in the flying of our aircraft, but also in the way we design them.
So there are different technologies ongoing, clear use cases. We are approaching the D-Day, so we have two great startups sitting here, QuantumDiamonds and Planck. So from your perspective, when are they ready to collaborate with you? What's important that it makes sense for you to really work with the startups out there?
I mean, I will not reveal anything, but we are working with startups and with one of them sitting here as well. But yes, I mean, we are technically engaged with the ecosystem very much. And as well with our venture capital arm, we are actually engaged into different startups in order to really profit from the speed and from the quickness that we can get there, and it's very different directions actually. And of course, there's plenty of them. We are always looking 360 degrees.
Yeah, perfect. Great to hear. Maybe from the other perspective, to Marcus and Kevin, from your perspective, what's important for you when you're working with a corporate? What's important for you? What needs to be done on the corporate side that it does work for you? I don't know, maybe Marcus, you want to start?
Yeah, for us it's really important like to get close to the real computational pain points, also to real problems. Because what I observe sometimes in the industry is like that some players playing around with more toy examples and maybe having a nice kind of press release, but I don't think that's the way to go. So I think there's a win-win when we are getting access to their problems, because we can't anticipate them, and if we know them, it has a kind of impact, say, on our offering, even on our hardware, where you can just think, okay, we can go in this direction or this direction. So that's why at Planck we also have like a unit which actually is working on industrial use cases, and it's not like, say, maybe aerospace, it's also like finance, so it's really broad. And we're really speaking with a lot of corporate players to really understand first their problems and then see, okay, how we can help them, so on, say, on the algorithmic side, but then going also back into hardware and say, okay, what can you make better? So for us, it's really important, like, to get the real problems, not like any kind of like, let's do something with quantum to make a nice press release. I don't think that helps anybody.
So both sides really need to understand the same problem and then work on the solution. Kevin, is there anything else you want to add?
I would 100% agree. So I think what we are always looking for is a clear problem statement. So someone who says, we need better sensors, right? So we are willing to pay for a top-notch solution, and someone who is also understanding the expectations. So what we have seen is over the last 3 years that we have been becoming faster by 10,000 times. So if we project this to the future, even though we are not fast enough to basically image a full wafer in modern chip making, then we expect from the partner to see the potential of the technology. And this is where, in the beginning, we always align expectations that it is a new emerging technology. Quantum sensing already has the commercial impact, but still there's 99% of the work still to be done on actually integrating it into the customer's processes.
Yeah, perfect. Maybe let's add on this, because QuantumDiamonds, you founded the company many years ago, some years ago, very from quantum perspective, some years ago. And at UnternehmerTUM, we already talked about it. We were the very first investor, and of course are very proud what you achieved so far. And oftentimes, it's well known that quantum sensing is the most mature quantum technology. So maybe you already touched upon that, but what is the clear value you are delivering to the customer?
So I think quantum sensing, from my perspective, is a bit easier to understand as a non-quantum physicist, right? So you can think of this as microscopy, but way better, right? So whereas in like modern chip making, you have a lot of metal layers, right? So you want to check your integrated circuit for some defects, and you cannot look through. Yeah? And if you look a bit into semiconductors, they get stacked, like 15, 12, 18 layers. And the question is, how can we make sure that they work reliably? And there, if you use a conventional microscope, you cannot really see through the stack. And we can, similar to an X-ray system, in the sense of I can really see through the stack, we can make this visible. And this is simply impossible with modern microscopy tools. So I think it's, in quantum sensing, a bit extending what is sensible, whereas I think in computing, for a non-physicist, it's hard to get to the basics, I would say. Yeah.
Absolutely. So I think we have understood quantum sensing, so let's talk about quantum computers. So how do you do that to convince the customer, or at least a corporate who will be a customer in the future, hopefully, to work with you together, and not someday, because there is so much risk and the timelines are quite long. What's your pitch?
So the timelines are around 5 to maybe 10 years until we have something where you can say it will solve industrial problems. At the moment, we have more, say, experimental machines which can't do these kind of complicated problems out there, but it will be like maybe in 5, 10 years. So 5, 10 years sounds like a really long time, but I don't think so, because I have a finance background, so if you have an impact in the future, you can discount it to now. So if the impact is really big, and even it's like 5, 10 years, so you can measure it already. So if it would be a small impact, I could sleep very well. And the thing is that from that perspective, it's really important to look into that, because quantum computing, it's a kind of fundamental kind of technology which impacts not like one industry, but a lot of industries. So probably everybody will be affected by that. And so people have to look into, say, their problem cases or their operational point or computational pain points and see if there's anything. Because if there's something, maybe a competitor will be faster and will generate value or really huge impact in the future. So from this perspective, you have to act early. And the thing is, even in 5 till 10 years, it takes time to build these capabilities, because it's a complete new paradigm. So you have to get people, you have to understand the ecosystem, you have to find partners, you have to identify your own problems. And this is a process which probably takes something in this kind of order. So, and the funny thing is, even with quantum computing, it doesn't mean that you need a quantum computer for your problems. Even if you can, there's kind of, say some mathematics voodoo, where you can push your problems in the direction of quantum computers, and even with an immediate step, you can even improve your problems on classical hardware. That's a funny thing. And you even get a kind of strategic kind of perspective of what can be done, because when you have done this kind of exercise, you know what you need. If you know what you need, you can build a strategy around that. So this is something really important here. So this is one point you tell clients. And the other thing is really this kind of disruptive nature, because like when you can put stuff on a computer, essentially, or use raw computational power, you can maybe reduce costs really heavily because you don't need manual processes. And the other thing with quantum computers, you open new kind of computational frontiers. Like we are at the moment somehow bounded with our computational power. And if you have solved that, we are entering in new stages like Columbus, discovering America. So we have new territories we can explore and we can use to our advantage in companies.
Absolutely. So talking about frontier technologies, Jasmin, you are a partner at Onsight Ventures. You also invested in QuantumDiamonds, and you invest a lot in deep tech and especially in quantum topics. So how do you structure investments? What's important for you? Maybe also what is a research project and what's a company that can be a scalable quantum company in 5 years maybe, when you invest?
Yeah, I mean, if you have a fund, I believe diversification is, of course, important, but also picking the winners. We have therefore invested with our first fund in one quantum computing company, one quantum sensing, one quantum communication, and one quantum software company. And what I think is really important is to not only look at these companies that can supply, but pick the ones who can really win a market with founders who are charismatic and who are able to grow, who really have this mindset. I think Kevin is one of the best examples that I can give. They should be able to work independently with corporates. And I believe on the corporate side, some lucky corporates were also able to hire quantum physicists. So they really know what's going on, and they can then, of course, talk on a different level, startup and corporate. And I believe it's also a small market. So if you want to invest in this market, you need to be there. You need to try to get close to the research groups, trying to find out, is a new startup coming up, and so on and so forth. And also, being there and offering chances to maybe get to know investors like we do in Innsbruck with the Hermann Hauser Frontier Lab. I believe this has always played out quite well, that we not just only invested, but also tried to do something for the ecosystem, like you also do here in Munich. So, yeah.
So there is a lot of opportunities within this quantum.
Yes.
So I think we all conclude that we have this budding quantum ecosystem, but maybe yet now one sentence to close it up. What do we need to change, or what do we need within the next 5 years that we really have this flourishing quantum ecosystem, not only here, but also throughout Europe? Kevin, do you want to start?
I start. Okay. So I think what I've seen is that Bavaria starts their own program, then Baden-Württemberg start their own program, right? And I think we are competing on a global scale. Like if we ship our systems, we don't compete, as previously said, with someone in Stuttgart, but someone in San Francisco, right? And I think, of course, there's also a lot of stuff going on in Munich to build up a local ecosystem, but I think it will be global. Munich will not be the only hub in the world where every quantum company will be. So I think the initiatives should not be overlaid. I think they should be really focused and then kind of across Europe. Yeah? We have seen this in funding where there's some European legislation that says you have to put a bit of quantum money in quantum sensing in every member state. So it simply doesn't work, right? So at some point you have to pick the winners and think of this from like a European perspective, that we're not competing here in Bavaria, but really on a global scale.
So smartly join forces on the European level. Perfect. Jasmin, anything that?
I can only agree. We need more consolidation, and also if it comes to the public funds, we need to be more picky. I don't think that the Gießkanne really works in this area.
So pick the winners to make it work. Sabine, from the
Airbus, I think, is still a bit one of the European startups which has now grown up over the last 50 years. And of course, this point of consolidation versus we put a little bit of everywhere. We don't need to compete between each other here, but we need to consolidate in order to be big enough and able to scale. And then it's all about putting the right ecosystem together. So for us, it's crucial. We will not go into the actual research. We want to go into the implementation and then pick the strengths that everybody has and collide rightly.
Join the forces. From your side, Marcus.
When I'm looking in this direction here, so like Airbus, I think it's a good example because they can compete with Boeing and they're doing very well. And we should do exactly the same thing, quantum computing, quantum sensing, especially in quantum technology. We shouldn't just put money like in small pieces here and there. We should just put a big ticket and we should like maybe create something like Airbus again. So I think this is the way to go, and this is much bigger tickets. But the problem is, like, I think in Europe, we sometimes have this problem that we have really good research, but we don't have a good pipeline. I mean, that's what I think in the talk before, there was something similar with we don't have these really highly efficient capital markets. So this is also something we need. But we have to improve our pipeline so that we can get from research to really like unicorns and even bigger, that we can compete on the global stage, because at the moment, this is a global race, and this is not a race with, you mentioned like Stuttgart or something.
So, supporting the entire journey in
Sure.
So thank you very much for listening. Thank you very much. I think we all agree that there is a great possibility in the quantum market for Europe, and hopefully QuantumDiamonds or Planck will be the next Airbus.